Recording in progress.
Good morning, students. We're going to be working on section 3.3, more linear equations. So this is really just about getting some practice with our linear equations. So we'll begin. Okay, so our objectives are today just solve equations of the form ax plus b equals dx plus c. So in these equations, we're going to be adding or subtracting and multiplying and dividing. So they're two-step equations. So our general procedure for solving linear equations that simplify to the form ax plus b equals dx plus c. Simplify each side of the equation by removing any grouping symbols and combining like terms on both sides of the equation. We're going to pause right here. Okay, so we're actually back again. Sorry about that. I just had to make sure some things were happening. So general procedures for solving linear equations is first simplify each side of the equation by removing any grouping symbols. So if you need to distribute on either side, make sure that you do that. Then combine like terms on both sides of the equation. Second, you're going to use the addition principle of equality and add the opposites of the constant term or a variable term to both sides so that the variables are on one side and constants are the other side. You get to choose which side you want the variables. And then 3, use the multiplication or division principle of equality to multiply both sides of the reciprocal of the coefficient of the variable, or divide both sides by the coefficient itself. Our goal is to get the coefficient of the variable to become a positive 1, and then you check your answers. So let's go ahead and look at these 3. You'll notice on A that I have x's on both sides of the equation. I also have constants on both sides of the equation. So I get to choose what side I want to move the x's to and what side I want to move the constants to. Generally, I like to move the x's to the left, but sometimes if I'm trying to keep the whole equation a positive 1, I will move it to the right. But in this case, I'm going to subtract 2x from each side. Well, but they're going to subtract 3 from each side. And then they're going to do the 2x. And then if you notice, we end up with 3x equals a negative 21. And a negative 21 divided by 3 would equal 7. A negative 7, that is. So x in this case would be a negative 7. You can plug it in and check. And there you have it. Here's the next one. I'm going to collect like terms on both sides. I can see that 4x and a negative x are the same term, like terms. So I'm going to combine them. That will give me 3x plus 1 on the left. And I noticed on the right-hand side, the constants, I had 2 constant terms, so I can combine them and get 2x minus 8. Then I'm going to move the x's to the left-hand side by subtracting 2x from each side. And I'm going to move the constant of 1 to the right-hand side by subtracting 1 from each side. And now they'll do the x's. And we get x equals a negative 9. We could check that by substituting it in. And sure enough, a negative 26 does equal a negative 26. In this case, I have y's on both sides and constants on both sides. I'm going to start by subtracting a negative 2 point. Well, actually, if I subtract 7y and I move my y's to the left, I'm going to end up with a negative y. And I don't think I want to start with a negative. I think what I'll do is add 3.6 to each side. So I'm going to move my constants to the left this time. And I'm going to move my variables to the right. And the reason I do that is because I want my y value to be positive. I don't want to have to take one extra step, which is dividing by a negative 1, although it was very simple to do. And then we check it. 6.1 into both places, multiply it out, add them together, and both sides equal 39.1. Therefore, we are looking at a true statement, and therefore we have shown or solved for x. The x could equal 6.1. Or does equal 6.1. So here's 3 more of the practice. Notice we have parentheses on 2 of them, and we have fractions on the 3rd. So ones with the parentheses, we're going to want to distribute first. So let's look at A. So A, I'm going to distribute the 2 on the left-hand side and the 4 on the right-hand side. And the 4 is only timesing the y and the 1. It is not timesing the negative 26, so make sure you don't do that. And of course, over here, the 2 is timesing the y, and the 2 is timesing the negative 7. So we distribute. And now on the right-hand side, we've got some like terms that can be collected. So we'll collect those. And now I'm going to, in this case, I think I want to move the y's to the left and the constants to the right. So I'm going to add 22 to both sides, and then I'm going to subtract 2y from both sides. And that finally leaves me 8 equals 2y. Now I'm at the division part of this. I'm going to divide both sides by 2. And 8 divided by 2 is 4. And 2y divided by 2 is y. And we have solved. We can then go back and do the check where we stick the 4 in and check. But we're not going to do that. For time's sake, we're going to move on. But you can do that. So this one, once again, we want to distribute. This negative is attached to the negative 2. So when you multiply, make sure that that negative is multiplying through. And also over here and here. So I get a negative 10x minus 26 minus 2 equals a negative 18x plus 12 minus 41. And now I have some like terms right here and like terms right here. So I go ahead and collect those. And I think I'm going to want to once again move the x's to the left and the constants to the right. So I'm going to add 28x to each side, and I'm going to subtract or add 18x to each side. So I then end up with 8x minus 28 equals negative 29. Subtract or add 28 to each side, and I get 8x equals a negative 1. Now I need to divide by 8 on both sides, and x ends up equaling a negative 1/8. And you can see how that worked. Now, it doesn't matter if I add the x's first, like they did in this case, or if I add the constants first, but I do need to do the addition part or subtraction part first. Then notice we did the multiplication later. Okay, in this case, I am going to want to clear that parenthesis, and I look at 3, 6, 5, and 10, and I recognize that the nearest or the least common multiple that they'll all go into is 30. So I'm going to times everything by 30, both sides, and so I end up with 30 times 1/3 over x plus 30 times 1/6 equals 30 times 2/5 x, and a negative 30 times 7 over 10. When I multiply those out, 30x over 3 is really just 10x. 30 over 6 is really 5. 60 over 5 is 12. And then negative 210 over 10 is a negative 21. And now I'm going to move my x's, I think, to the right, and my constants to the left by subtracting 10x from each side and adding 21 to each side. And they're like, no, we're going to do it different. This time we want to have negatives, and we'll see what happens because, like I said, it doesn't matter. Notice now that I have a negative 2x equals a negative 26. All I have to do is divide by a negative 2. No problem. X equals a negative, well, a negative 26 divided by a negative 2 is a positive 13. So x equals 13. This time they decided I'm just going to keep the x's on the left, and you can do that every time if you want. If it makes it easier for you to always just keep your variables on the left, then do that. Okay, so here we have a student bought a calculator and a textbook for a total of $200.80. If the textbook cost $20.50 more than the calculator, what was the cost of each item? So in the end, I want to know the calculator and the textbook. What are their costs? That's what I'm looking for. Well, I'm going to look at this sentence right here. If the textbook costs $20.50 more than the calculator, notice I'm comparing textbooks to calculators. So I am going to let calculators be X. And then I can write the textbook cost because it's $20 more than the calculator. So it's $20 plus X. If I let the calculator be X, then $20 more than X is X plus 20.5. And now I have the two of them, and I know their total right there. So I can set up this equation of X plus $20.50, that's the cost of the textbook, plus X, the cost of the calculator, equals $200.80. Now I'm ready to combine any like terms, aren't I? So 2x plus $20.50 equals 280, or $200.80. I'm then going to subtract $20.50 from both sides, and I get 2x equals 180.3, or I end up with x equals $90.15. I can then, that's the calculator. Remember over here, I knew the calculator, but remember the calculator is less than the textbook, and the textbook is how much more? $20.50. So I'm going to add $20.50 on this to get the textbook. And so I get 110.65 for the textbook. And so now I do know the cost of both items, and I have completed what the question asked of me, the cost of both items. All right, so here are some work problems for you to do. Please pause the computer, try these on your own, and then repause it or unpause it to see the solution. All right, so let's begin with number 1. We have x plus 14 minus 6x equals 2x minus 7. I notice these like terms here. So I get 14 minus 5x equals 2x minus 7. I think I'm just going to subtract 14 from each side. And that gives me a negative 5x equals 2x minus 21. And then I'm going to subtract 2x from each side. And that gives me, come up here, a negative 7x equals a negative 21. And then if I divide by a negative 7 both sides, I get x equals 3. So my answer here is x equals 3. Okay, let's do the next one. Here we go. Now you think, well, there's nothing to distribute, but there's a 1 right here. Okay, so I'm going to get this as 5. Now if I distribute that negative 1 through, I'm going to get minus y. And if I distribute that negative 1 here, I'm going to get plus 3 equals 14 minus 4y, that's from here to here, and then minus 8. And now I could collect any like terms. My like terms are here and here. So 8 minus y equals, what is 14 minus 8? That would be 6 minus 4y. And I'm going to move the y's to the left, the constants to the right. So I'm going to subtract 8 from each side. And I'm going to get a negative y equals a negative 2 minus 4y. And let's see. I'm going to add 4y to each side. And that gives me 3y equals a -2, or y equals a negative. If we divide by 3, let's put it up here. 3y equals a -2. I'm going to divide by 3, and I get y equals a -2/3. And that would be my answer there. Okay, let's look at the next one. Oh, I've got 14, 4, 7, and 4. And I got a number that they all three go into, and I know that happens to be 28. So I'm going to go 28 times 3/14 times n plus 1/4 equals 28 times 1/7n minus 1/4. And if I distribute that through, 28 times 3, well, let's do this. 28 times 3/14 n plus 28 times 1/4 equals 28 times 1/7n minus 28 times 1/4. And so 28 and 14, they both have 7s that go into them. It goes into this one 4 and this one twice. But actually, let's back that up a little bit. 14 goes into 28 just twice. And so I'm going to put a 2 there. 2 times 3 is 6. So I have 6n. 28 and 4, well, that reduces down to 7. So I just have plus 7 equals 28 and 7. That reduces down to 4. So 4n minus, and 28 divided by 4 is 7 minus 7. And so I'm going to subtract 7 from each side. And I'll take that up here. And I end up with 6n equals 4n minus 14. And then I'm going to subtract 4n from each side. And that leaves me 2n equals a -14, or n equals a -7. That was 5. Now, on this one, I can keep it just as a decimal, and I think I probably will. Although I could clear the fraction. I don't think I want to in this case. I'm just going to subtract from each side. I'm going to subtract 2.1. I'm going to subtract 2.1 from each side. And that was a minus and a minus. So over here I get 6.4. X equals 3.1 x minus 3.3. And if I take away 3.1 x from each side, that's going to give me 3.3 x equals a -3.3, or x equals a -1. If I divide both sides by 3.3, I'm going to get x equals a -1. So that one was a -1. And our last one, the fraction that I would clear, is the 2, 3, and 6. They have a 6, so I would times everything by a 6. So I would get 6 times 2x/3 minus 6 times 1/2 equals 6 times x plus 6 times 1/6. And 6 and 3, they'll reduce down. I'll do my pre-reducing. That's 2. 2 times 2 is 4x. Over here, I'll do my pre-reducing. That's a 3. So minus 3. And over here, that doesn't reduce. That's just 6x. And over here, they reduce, cancel each other out, leaving me just 1. And now, I think what I'll do is subtract or add 3 to each side, leaving me 4x equals 6x plus 4. Then I'm going to subtract 6x from each side, and that'll give me a -2x equals 4, or divide by a -2 both sides, and I get x equals a -2. And so I have completed all those. Let's check just to make sure that I got them right. 3, -1, -2/3, -2, and -7. Is that what I got last? Yeah, for 5 I got -7. 4, -2, good. 3 was a -2/3. Okay, so we have done them correctly. Go ahead, make sure you work on your derivative assignment, and hopefully this will help you with completing those other problems. Have a good day, and I hope all is well with you and your class. All right.